Gather round and let me spin you a tale of one man, one problem, and one ESP32 module made from scratch. A tale of pressing 2 buttons, one for resetting, one for mode selection. A tale of triumph. A tale of automating the last button pressing responsibilities known to man. For today, we reinvent the button, using these 2 transistors right here. But first, there's just one problem. We need something for our buttons to press, lest we forget why we press them. Today, we're going to be making a custom ESP32 board. Something akin to these off-the-shelf affairs, albeit with a lot more class, a lot more wires, and a lot less practicality. And yes, before you ask, it can play Doom. But we don't have time to laze around playing games today. We've got work to do. Soldering. Armed with a college-grade hotplate and the nearest pointy stick, we're applying solder paste to this PCB in the manner of our cave-dwelling ancestors. By that, I mean that this paste is very old, very expired, and very sludgy. A little preheating of the hotplate helps. There's just one problem. A little too much preheating and your paste turns into some delightfully silver liquid prematurely. I'm sure we've all been there before, but typically you don't want your paste to turn silvery until you're actually soldering components with it. It turned out fine here, just a word of warning to any intrepid DIY PCB makers out there. Well, we have a fully functional ESP32 module now. It doesn't quite look as fancy as the off-the-shelf models do, but technically none of those bits are strictly necessary anyway, so we're gonna call it good here. There's just one problem. While this board is technically fully functional thanks to the room module doing the heavy lifting for us, it would be incredibly tedious to actually use. Most ESP32 modules come with 2 buttons on the board. These buttons are connected to the enable pin and GPIO0 of the ESP32. With a couple of pull-down resistors, these lines are driven low when the buttons are depressed. Holding the IO0 button down when releasing the enable button tells the bootloader to boot into firmware flashing mode instead of regular running mode. There's just one problem. If it were only 1 button, I wouldn't think twice, but 2 buttons? My name isn't Presser. Enter stage left. The magnificent, the spectacular, the fantastic, the auto reset circuit. This glorious homage to programming efficiency allows for automating the process of pressing 2 buttons. It works in conjunction with a UART to serial converter like this off-the-shelf FTDI231 XS-based monstrosity. Modern internet whiz kids have overloaded the original serial port functionality of these chips to enable some truly efficient programming behavior using a couple of otherwise unused connections. The programmer, through some black box scientific mumbo-jumbo I've never bothered to learn, drives these lines high or low as needed to power our auto-resetting logic circuit. In this case, the RTS and DTR pins. These pins work their magic through these 2 transistors in our auto-reset circuit, driving the ESP's enable and GPIO0 pins high and low as necessary like we previously did with the 2 buttons. In other words, what you see before you is an electronic brain, brought to life that it may forever do the work of pressing 2 buttons. Bow before your new electronic overlords, for they will automate all your button-pressing responsibilities. Sorry, I get a little carried away when talking about logic circuits. For all my dramatic exposition, this actually is pretty fascinating. It may not look it, but what we just did is a fair representation of the basics of every computerized device you've ever used. albeit with each transistor doing 1/quintillionth of a thing rather than pressing 2 buttons. There's just one problem. This off-the-shelf UART to serial conversion board doesn't expose the RTS pin that the programmer uses to drive the logic circuit. There are a couple of ways to solve this problem. One is to just solder a tiny wire to these tiny leads on this tiny PCB. Being not so tiny myself, the prospect of such an endeavor speaks to me about as much as the prospect of pressing 2 buttons does. The second solution is to use the exposed CTS pin on the board in place of the unexposed RTS pin. To be honest with you, I have no idea how to approach this, and it sounds like a software maintenance nightmare when I inevitably forget what I did and have to replicate it all again every time I reinstall PlatformIO. The third option is invention. And by that, I mean making more PCBs in this video about making these exact PCBs. Wait, what? This is where we make the rest of the ESP32 module. The bits that you would typically see on an ESP board that don't consist of 2 buttons. There's just one problem. Bed leveling. No, not that kind of bed, nor that kind of leveling. You see, the tolerances in PCB manufacturing are incredibly tight for a 2-button hobby-grade machinist like myself. The big issue is that the typical tooling used for isolation routing is in the shape of a V, so the tip doesn't snap off immediately upon contact with the work surface. Meaning that as the depth of cut increases, so too does the width of the cut, through a phenomenon known as math. My first solution was to bury my head in the sand and ignore the issue entirely. By specifying a track width larger than what is strictly necessary when designing the PCB, we buy ourselves a bit of precious tolerance. This allows for some tracks, in the final result, to deviate from the design, some thinner, some wider, but all connected. Or at least, that's the idea. It worked for the ESP32 breakout module, but that was a very simple circuit that allowed for plenty of deviation. For a more complicated circuit, like this auto reset board, with lots of interconnected components, jumpers, and only having a single copper plane to work with, the tolerances become much more specific. I spent more time than I want to admit trying this half-assed approach. A graveyard of copper-clad boards, my only recompense. May they rest easy. My laziness resulted in their demise, but their sacrifice was not in vain. For upon the detritus of their carcasses I found the one true path, at long last. The solution to our singular problem was right in front of me the whole time. In situ machining. Say it with me. In situ machining. By installing a piece of plywood onto the router's table and machining it in place, we get a PCB work holding surface that is as level to the cutter as it can possibly be. There's just one problem. Remember how we applied solder paste before? By just manually sticking it to the pads with a moderately pointy stick. Well, that works okay there, with the big solder pads and a bit of heat. But with pads this tiny, we're going to need an exceptionally pointy stick. Unless there's a better way. Enter stage left. Lasers. This is a stencil, specifically a stencil designed for applying solder paste. There's just one problem. Typically, these stencils are made of metal. That metal is a very specific thickness. This thickness controls how much solder paste is applied to each pad. Without the ability to precisely machine extremely thin sheet metal with this type of tolerances, though, the DIY PCB maker's girth is at the mercy of paper manufacturers. For us, the amount of solder applied to each pad isn't determined by thickness, but by the size of the openings made in our stencil. The paper versions aren't good for more than a few uses at a time, but with some less expired solder paste, you can actually get a couple of applications from a single stencil before needing to laser out a new one. With solder applied, and determination in our hearts, we're finally ready to build our auto reset circuit that surely has no problems whatsoever.
There's just one problem.
Some of you may have noticed this already, and to those I applaud your diligence, but next time maybe speak up sooner so I don't waste so much time chasing down one problems. This issue right here. Do you see it? These two transistors should be connected in the same manner, like on this SparkFun published reference schematic. Oh, the lamentations I lamented. Years of embarrassment looming over my pride, ignorant of this festering pustule of a mistake. As is tradition, though, this problem was hidden behind a plethora of other just one problems. There was a short under this protection diode due to an incorrectly selected pad size in KiCAD. Easy enough to resolve with some surgery using a scalpel. There were some less obvious shorts, likely caused by a bit too much paste applied in some particularly sensitive areas. These resistors on the RX-TX lines that I have absolutely no clue why I included in the design. Again, easy enough to resolve by manually soldering in some 0-ohm resistors. The USB connection immediately snapped off on first attempted use, clearly showing that the component didn't get enough heat, resulting in the solder only adhering well to the copper and not to the component. Some precise manual resoldering and a bit of hot glue fixed that. And last, the one problem to rule them all. And in the darkness, find them. At this point, I'd spent so much time manually revising the plethora of problems on this PCB that there was no chance in hell I was going to scrap it and make a new one just because two connections aren't connected to the proper connecting points. Surgery it is, then. With careful application of a very sharp object to break the incorrect connections, and a bit of very, very tiny wire soldered to make the correct connections, mastery over Sauron and his evil legion was finally achieved. And with that, all our singular problems have ceased. The long travail of the one problem reaches its destined conclusion, and we can return to the Shire for our long-fated honeymoon with Samwise Gamgee. We rise today more complete than the days prior, stronger, more confident. We finally find the light at the end of our long, dark tunnel. Wait, something doesn't feel right here. Could it be that there is still one more problem? Stay calm. I know what to do, friends. Ah, there it is. Copper. Red, and blue. All of the colors imaginable. My gamer soul is truly, finally, at peace, and we can all rest a little easier knowing that there is one less problem in the world.